I really fucking hate today. Fucking, it's just so many things have gone wrong. I'm late to the stream. It's been a bitch to set up. What the fuck? Holy shit. Okay. Hello, everybody. It has been a bitch today. Okay, I want to learn how to program today. You read that right. I want to learn. There's a hair. Ew. I want to learn how to program today. So, I have come to this website that I have found called Learn CPP or Learn C++. Essentially, a college textbook's worth of learning how to program for free, just on the internet, and I'm gonna boop, put on some fucking music. Maybe turn that down just a tad. Just a tad. Anyways. Hopefully somebody joins me. But if not, that's fine too. But yeah, I started this a while back. I kind of forgot everything since then. I only finished like one or two chapters. But yeah, I seemed to like this one. There was a lot of comedy. There was a lot of programming humor. Of just like, you know, if you don't know how to do something, Google it. Just grab it from somewhere else and fucking hope it works. So we'll learn. And I have this thing, fucking Visual Studio. This was the bitch to set up. This was the biggest bitch to set up. Cause this is the free trial version. I had to uninstall and reinstall it to get a new trial version. So yeah. Okay. Welcome to Learn C++ tutorials. Above all else, these tutorials aim to make learning C++ easy. Unlike many other sites and books, these tutorials don't assume you have any prior programming experience. We'll teach you everything you need to know as you progress, with lots of examples along the way. Whether you're interested in learning C++ as a hobby or for professional development, you're in the right place. The lessons in this introductory chapter are aimed at giving you some context around what C++ is, how it came about, how programs work, and what software you need to install to create your own programs. You'll even write your own first program. Further chapters will explore different parts of the C++ language. In the first chapter, Chapter 1, you'll get a broad but shallow overview of many fundamental C++ concepts, so we can start writing some simple programs. Further chapters will explore these concepts in depth or introduce new concepts. Each chapter has a theme, with all of the sections underneath it being generally related to that theme. There is no suggested amount of time that you should spend with each lesson or chapter. Progress through the material at a pace that is comfortable to you. Before we get started, let's hit on a couple of important goals of these tutorials. Oh yeah, I will mention, I also had to install an ad blocker, cause this site is fucking full of them. There is ads on the sides, there's ads in front of everything, there is ads in the middle of stuff, there is just ads everywhere, and it's a lot. It's a lot. So I put on an ad blocker, just in case. I don't want a fucking weird ass ad coming up and looking weird. So it seems like the introductory is essentially just telling me like what to expect. So this site is free because it is supported. If you find yourself enjoying the lessons, please consider disabling your ad blocker. And there you go. If you want to support them, disable the ad blocker. Like I said, the only reason I have it, I don't want something weird popping up and I get banned. So yeah, I just feel it's safer. Just in case. Because the ads are a bit spammy. Introduction to programming languages. Oh yeah, and I also have video, like I showed. I have video playing again. There's your website if you want it. So, this looks like more definitions and stuff. Computer program, also commonly called an application, is a set of instructions that the computer can perform in order to perform some task. The process of creating a program is called programming. God, I need to fucking do like warm-ups or something beforehand. Programmers typically create programs by producing source code, commonly shortened to code, which is a list of commands typed into one or more text files. I keep fucking twisting my tongue. Like coffee. Alright. So, what is this? High-level languages. To address the readability and portability concerns, new programming languages such as C, C++, Pascal, and later, languages such as Java, JavaScript, and Perl. I have no idea what Perl is. Or Pascal, for that matter. Were developed. These languages are called high-level languages, as they are designed to allow the programmer to write programs without having to be as concerned about what kind of computer the program will be run on. Here's the same instruction as above in C, C++. A equals 97. Was that a program up here? Maybe. I know I'm skipping around, it's just... much like assembly programs written in high-level languages must be translated into a format the computer can understand before they can be run. There are two primary ways this is done: compiling and interpreting. A compiler is a program that reads source code and produces a standalone executable program that can be run. Once your code has been turned into an executable, you do not need the compilers to run the program. In the beginning, compilers were primitive and produced slow, unoptimized code. However, over the years, compilers have become very good at producing fast, optimized code, and in some cases, can do a better job than humans can in assembly language. Simplified representation of the compiling process, so... Okay, so essentially, you get the source code, gets compiled, and produces the executable. And then this runs it faster than what the raw data would. I think that's right. An interpreter is a program that directly executes the instructions in the source code without requiring them to be compiled into an executable first. Oh, so the interpreter is the one that... Okay. Okay, so the interpreter is the one that actually runs the program without having to use raw code. I think I got that. First high-level language. Where are we? High-level languages have many desirable properties. First, high-level languages are much easier to read and write because the commands are closer to natural language that we use every day. Second, high-level languages require fewer instructions to perform the same task as lower-level languages, making programs more concise and easier to understand. In C++, you can do something like A equals B times 2 plus 5 in one line. In assembly language, this would take 5 or 6 different instructions. Oi. Third, programs can be compiled or interpreted for many different systems, and you don't have to change the program to run on different CPUs. You just recompile for that CPU. As an example, high-level code can compile for x86, PowerPC, or MIPS hardware, and perform that executable. Nice. Two general exceptions to portability. The first is that many operating systems, such as Microsoft Windows, contain platform-specific capabilities that you can use in your code. These can make it much easier to write a program for a specific operating system, but at the expense of portability. In these tutorials, we will avoid any platform-specific code. Some compilers also support compiler-specific extensions. If you use these, your programs won't be able to be compiled by other computers that don't support the same extensions without modification. We'll talk more about these later once you've installed a compiler, which I already have, at least for right now. Rules or instructions you must do as required by the language. Fail to abide by the rule will generally result in the program not working. Yeah. Best practices are things that you should do, because that way of doing things is generally considered a standard or highly recommended. What the heck did I just say? That is, either everybody does it that way, and if you do otherwise you'll be doing something people don't expect, or it is superior to the alternatives. Warnings are things that you should not do, because they will generally lead to unexpected results. Nice. The history of C, I don't really need that exactly. Cool to learn, but yeah, I don't really need to know the history of it. Not really. Yeah, this is kind of pointless. Just the history of C++, not exactly necessary to learning how to write it. Introduction to C++ development. Before we can write and execute our first C++ program, we need to understand in more detail how C++ programs get developed. There's a graphic outlining a simplistic approach. So, define the problem, design the solution, write a program that implements the solution, compile said program, link object files, test the program, start the debug, and loop until it's good. Until it fucking works. Find the problem you would like to solve. So, for example, I want to write a program that will allow me to enter many numbers, then calculates the average. I want to write a program that generates a 2D maze and lets the user navigate through it. User wins if they reach the end. I want to write a program that reads in a file of stock prices and predicts whether the stock will go up and down. Went from a calculator to how to get rich quick. Determine how you're going to solve the problem. This is the how step, where you determine how you're going to solve the problem you came up with in step 1. It is also the step that is most neglected in software development. The crux of the issue is that there are many ways to solve a problem. However, some of these solutions are good and some of them are bad. Too often a programmer will get an idea, sit down, and immediately start coding a solution. This often generates a solution that fails into the bad category. Falls into the bad category. Sorry. Typically, good solutions have the following characteristics. They are straightforward, not overly complicated or confusing. They are well documented, especially around any assumptions being made or limitations. They are built modularly, so parts can be reused or changed later without impacting other parts of the program. They are robust and can recover or give useful error messages when something unexpected happens. When you sit down and start coding right away, you're typically thinking, I want to do something. So you implement the solution that gets you there the fastest. This can lead to programs that are fragile, hard to change or extend later, or have lots of bugs. Technical defects. As an aside, the term bug was first used by Thomas Edison. Huh. However, the term was popularized in the 1940s when engineers found an actual moth stuck in the hardware of an early computer, causing a short circuit. Both the logbook in which the error was reported and the moth are part of the Smithsonian Museum of American History. Oh, really? What? Sorry, side note, what? That's fucking cool! The first actual computer bug was literally a bug. That's cool. Yeah, American engineers have been calling small flaws in machines bugs for over a century. Thomas Edison talked about bugs in electrical circuits in the 1870s. When the first computers were built during the early 1940s, people working on them found bugs in both the hardware of the machines and in the programs that ran them. In 1947, engineers working on the Mark II computer at Harvard University found a moth stuck in one of the components. They taped the insect in their logbook and labeled it "First Actual Case of Bug Being Found." The words bug and debug soon became a standard part of the language of computer programmers. Among those working on the Mark II in 1947 was mathematician and computer programmer Grace Hopper, who later became a Navy Rear Admiral. This logbook was probably not Hopper's, but she and the rest of the Mark II team helped popularize the use of the term computer bug and related phrase debug. That's fucking cool! Oh, but it's not on view currently. Aw, dang. Are there more pictures? What a cool fucking side note! Learning how to debug. Hey, here's the first bug. That's cool. That's cool. Okay. That's fucking cool. Anyways, back to topic. Studies have shown that only 20% of a program's time is actually spent writing the initial program. The other 80% is spent on maintenance, which can consist of debugging, removing those pesky moths, updates to cope with changes in the environment. For example, to run on a new OS version. Enhancements, minor changes to improve usability or capability, or internal improvements to increase reliability or maintainability. Consequently, it's worth your time to spend a little extra time up front before you start coding, thinking about the best way to tackle a problem. To tackle a problem, what assumptions you are making, and how you might plan for the future in order to save yourself a lot of time and trouble down the road. We'll talk more about how to effectively design solutions to problems in a future lesson. In order to write the program, we need two things first. First, we need knowledge of a programming language. That's what these tutorials are for. Second, we need a text editor to write and save our written programs. The programs we write using C++ instructions are called source code, or just code. It's possible to write a program using any text editor you want, even something as simple as Windows Notepad, or Unix's Vi or Pico. I have used Notepad before. Don't ever fucking use Notepad to do coding. It's a bitch. And it's dumb. Hell, I've even used Notepad... What is it? Notepad C++ or something like that. Don't ever use Notepad. Unless you want to rip your fucking head off. Holy shit, is it a bitch to use. Anyways. Yeah, strongly urge you to use an editor that is designed for programming, or code editor. Don't worry if you don't have one yet, we'll cover how to install a code editor shortly. A typical editor designed for coding has a few features that make programming much easier, including line numbering, useful when the compiler gives us an error, as a typical compiler error will state, the error, line, whatever. Without an editor that shows line numbers, finding line 64 can be a bitch. Syntax highlighting and coloring. Meaning, like, it'll color which type of thing it is. It'll show you at a glance what it is. An unambiguous font. You don't want fucking, cursive writing in your programming. That would look terrible. I'm sure that would look terrible. Programs you write will typically be named something .cpp, where something is replaced with a name of your choosing for the program. For example, calculator, high-low, etc. CPP extension tells the compiler, and you, that this is a C++ source code file that contains C++ instructions. Note that some people use the extension .cc instead of CPP, but we recommend you use CPP. Does it matter? Name your code files, whatever, where something is the name of your choosing, and CPP is the extension that indicates the file, yeah. Also note that many complex C++ programs have multiple CPP files. Although most of the programs you will be creating initially will only have a single CPP file, it is possible to write single programs that have tens or hundreds of CPP files. Ooh. Once we've written our program, the next steps are to convert the source code into something that we can run, and then see whether it works. We'll discuss these steps 4 through 7 in the next lesson. I'm gonna grab myself a drink. Nice, easy, instant coffee. It's good. So, same picture. Compiling your source code. In order to compile a C++ program, we use a compiler. The C++ compiler sequentially goes through each source code file in your program and does 2 important tasks. First, it checks your code to make sure it follows the rules. If it does not, the compiler would give you an error to help pinpoint what needs fixing, and the corresponding line number. The compilation process will also be aborted until the error is fixed. Second, it translates your C++ source code into a machine language file called an object file. Object files are typically named name.o or name.ob, object, where name is the same name as the CPP file it was produced from. If your program had 3 CPP files, the compiler would generate 3 objects. Okay. C++ compilers are available for many different operating systems. We will discuss installing a compiler shortly. I've already done that. Cool. Because I'm pretty sure I'll get to that before this stream is over. After the compiler creates 1 or more object files, then another program called the linker kicks in. The job of the linker is threefold. First, to take all the object files generated by the compiler and combine them into a single executable program. So literally, just everything goes into this and poops out next executable. Nice. Second, in addition to being able to link object files, the linker is also capable of linking library files. A library file is a collection of precompiled code that has been quote-unquote packaged up for reuse in other programs. What the fuck is this? Huh. The C++ core language is actually fairly small and concise, and you'll learn much of it in these tutorials. However, C++ also comes with an extensive library called the C++ Standard Library, usually shortened to Standard Library, that provides additional functionality that you can use in your programs. One of the most commonly used parts of the C++ Standard Library is the Iostream Library, which contains functionality for printing text on a monitor and getting keyboard input from a user. Almost every C++ program written utilizes the Standard Library in some form, so it's very common for the Standard Library to get links into your programs. Most linkers will automatically link in the Standard Library as soon as as soon as you use any part of it, so this generally isn't something you need to worry about. You can also optionally link in other libraries. For example, if you were going to write a program that played sounds, you probably would not want to write your own code to read in the sound files from disk. Check to ensure that they were valid, or figure out how to route the sound data to the operating system or hardware to play through the speaker. That would be a lot of work. Yes, it would. I'm sure it would. Yeah. Instead, you'd probably download a library that already knew how to do these things and use that. Just take something somebody's already made and use that. Don't do it yourself. There's no point in doing it yourself. Talk about how to link libraries and create your own in the appendix. You mean the very, very last thing in this book. Okay. Third, the linker makes sure all cross-file dependencies are resolved properly. For example, if you define something in one CPP file and then use it in another CPP file, the linker connects the two together. If the linker is unable to connect a reference to something with its definition, you get a linker error, and the linking process will abort. Once the linker is finished linking all the object files and libraries, you will have an executable file that you can run. And for the advanced, for complex projects, some development environments use a makefile, which is a file that describes how to build a program, which files to compile and link, or otherwise process in various ways. Entire books have been written about how to write and maintain makefiles. They can be an incredibly powerful tool. However, because makefiles are not part of the C++ core language, nor do you need to use them to proceed, we'll not discuss them as part of this tutorial series. Why is step 6... What? Why step 6 and 7? Testing and debugging. This is the fun part, hopefully. You are able to run your executable and see whether it produces the output you were expecting. If your program runs but doesn't work correctly, then it's time for some debugging to figure out what's wrong. We'll discuss how to test your programs and how to debug them in more detail. And note that they all use software, yes. Alright, installing the integrated development environment. I have already done this. If you would like to do it yourself, basically just get Windows Visual Studio. What is it, the community one? I think it's Community 2019? I think so. Yeah, Visual Studio Community. Yeah, this thing. Yeah, get Visual Studio 2019 because it's free for like 30 days, and then you have to uninstall and reinstall it. And make sure you install the desktop development with C++, and make sure at least this is checked. Everything else is fine. Just leave it as is. Or if you have other OSs. You got Windows XP, Vista 7, 8.x, and 10. Make sure to get the version of code blocks that has min.gw bundled. Linux users, maybe missing dependencies needed to run or compile programs with code blocks. And if you're on Mac, fuck you. Oh, popular Mac choices include Xcode or Eclipse. Eclipse is not set up to use C++ by default, and you will need to install the optional C++ components. Other compilers or platforms. There are plenty of them. Yeah, web-based compilers, such as Tutorials Point. What does that look like? Huh. So I'm sure if I just hit enter. Nope. How do you, oh. Yeah, so if you execute hello world, there's a bit of weird stuff that shouldn't be there, I don't think. Should just I thought it should just say hello world, not... Okay. I don't think that's supposed to print. Whatever. Leave the page, I don't need it. Can I use command line compiler? Yes, but don't recommend for beginners. Can I use other code editors or IDEs? Yes, but we don't recommend it for beginners. And IDEs to avoid! You should avoid the following IDEs altogether because they do not support at least C++11, do not support C++ at all, or are no longer actively supported or maintained. So yeah, Visual Studio for Mac doesn't support fucking C++, and Borland Turbo C++ does not support ++11. There is no good reason to use an outdated or unsupported compiler when lightweight, free alternatives that support modern C++ exist. When things go wrong, aka when IDE stands for I don't even. See, this is the fucking... This shit. This tiny shit, like, you know... They know you'll have questions like, what the fuck is happening? And they're like, yeah, that's gonna happen. Yeah, it's gonna happen where you just don't fucking understand what went wrong. And that's kind of just how programming works. IDE installations seem to cause their fair share of problems. Installation might fail outright, or installation might work, but the IDE will have problems when you try to use it due to a configuration issue. If you encounter such issues, try uninstalling the IDE, if it installed in the first place. Reboot your machine, disable your antivirus or anti-malware temporarily, and try the installation again. That was another bitch thing that I had to deal with. Reinstalling Visual Studio. You have to fucking restart your computer. I didn't know this, that's why I was late to the stream, but yeah. If you're still encountering issues at this point, you have two options. The easier... Excuse me, I'm about to choke. The easier option is to try a different IDE. The other option is to fix the problem. Fortunately, the causes of installation and configuration errors are varied and specific to the IDE software itself, and we're unable to effectively advise on how to resolve such issues. In this case, we recommend copying the error message or problem you're having into a Google search. Google your fucking problem. We're not your mom. Got it. Once it's installed, which can be one of the hardest steps if things don't go as expected, or if you're temporarily proceeding with a web-based compiler, you are ready to write your first program. Yay! Yes. Oh, cool. So I had to do this in a bit. Okay. So, project, container that holds all of your source code files, images, data files, etc. that we need to produce an executable, or a library, website, blah blah blah, that you can run or use. The project also saves various IDE, compiler, and linker settings, as well as remembering where you left off. Give me a sec. I had to fucking sneeze, and I didn't think you'd want to hear that. Each project corresponds to one program. When you're ready to create a second program, you'll either need to create a new project or overwrite the code in an existing project, if you don't want to keep it. Project files are generally IDE specific, so a project created for one IDE will need to be recreated in a different IDE. Nice. Create a new project for each new program you write. Good. When you create a new project, you'll generally be asked what type of project you want to create. All of the projects that we will create in this tutorial will be console projects. Console project means that we are going to create programs that can be run from the Windows, Linux, or Mac console. Yes. The command prompt. The thing that if you ever see, you're like, what the fuck do I do with this? Good. What is this? Gabriel Knight 3. Nice. I have no idea what the game that is. So, Don't worry if you never used a console before or don't know how to access it. We'll compile and launch our programs through our IDEs. Nice. When you create a new project for your program, many IDEs will automatically add your project to a workspace or a solution. A workspace or solution is a container that can hold one or more related projects. For example, if you're writing a game, you want it to have a separate executable for single player and multiplayer. You're insane if you want to do that instead of just bundle it both together. You need to create two projects. It wouldn't make sense for both of these projects to be completely independent. After all, they are part of the same game. Most likely, each would be configured as a separate project within a single workspace solution. Yes. Although you can add multiple projects to a single solution, we generally recommend creating a new workspace or solution for each program, especially while learning. It's simpler, and there's less chance of something going wrong. Traditionally, the first program programmers write in a new language is the infamous Hello World program, or the program has already written it for you. Most programs just do that. That is the, that is the default that pops up. Always. Almost always. So creating a project. So Windows Desktop Wizard. Just project 1. I can't see the fucking T. There's the T. There we go. Create. Which one do you want? Pre-compiled header. Yeah. There we go. That's weird. That's very weird. Huh. Anyways, I'm gonna... There we go. So now we've got these two. Well, actually, probably. Make this a bit better. There we go. Oh, that's so good. Okay. So much workspace. Alright. So the Windows desktop, creating a project in Visual Studio 2017 or older. I don't know. Visual Studio Solution Explorer. On the left or right side of the window, you should see a window titled Solution Explorer. Inside this window, Visual Studio has created a solution for you, Hello World. Within that, the name in bold is your new project. I just did project 1, you can do whatever you want, I guess. Within the project, Visual Studio has created a number of files for you, including Hello World CPP. Underneath the source files, tree item. Oh, you mean, okay. I was trying to figure out what the hell a tree item was. The drop down. Got it. In the text editor, you will see that Visual Studio has already opened Hello World CPP and created some code for you. A lot of code. Very odd code, because I don't know what pch.h is at all. I know what Iostream is. I don't know what pch.h. F7? Control Shift B? Is it? It says build succeeded. Control F5. There we go. Hello world. Nice. What the fuck is this? What is this? Is that a school project of a cow? What is that? What are you doing, person who wrote this book? An ARM project. In code blocks. Oh, I don't have code blocks. Linux user, okay. 2 common C++ problems. In this section, we'll address some of the common issues that new programmers seem to run across with fairly high probability. This is not meant to be a comprehensive list of compilation or execution problems, but rather a pragmatic list of solutions to very basic issues. If you have any suggestions for other issues that might be added to this list, post them in the comments section below. When executing a program, the console window blinks and then closes immediately. First, add or ensure the following lines are near the top of your program. Visual Studio users, make sure these lines appear after hashtag include pch.h. Is there... Wait. Is there stuff that's... That's weird. Wait. Oh. Oh. Whoop! I didn't mean to do that. I didn't mean... Oh, fuck. There we go. Thank you. That's weird. Second, add the following code at the end of your main function right before the return. Standard sign clear. Standard sign ignore. Numeric limits standard string size max. Ignore any characters in the input buffer until we find an enter character. Or standard sign get one more character from the user. This will cause your program to wait for the user to press a key before continuing, which will give you time to examine your program's output before your operating system closes the console window. Other solutions, such as the commonly suggested system pause solution, may only work on certain operating systems and should be avoided. Older versions of Visual Studio may not pause when the program is run in Start with Debugging F5 mode. Try running in Start Without Debugging's Control F5 mode. I ran my program and got a window but no output. Your virus scanner or anti-malware may be blocking execution. Try disabling it temporarily. Excuse me. Excuse me. I'm tired. Apparently. My program compiles, but it is not working correctly. What do I do? Debug it! Google! Google it. General compile time issues. When I compile my program, I get an error about unresolved external symbol, underscore main, or underscore when main at 16. This means your compiler can't find your main function. All programs must include a main function. There are things to check. Does your code include a function named main? Is main spelled correctly? When you compile your program, do you see the file that contains function main get compiled? If not, either move the main function to one that is, or add the file to your project. See 2 chapters in the future. Did you create a console project? Did you create a console project? Try creating a new console project. I need more liquids. Iced coffee. Not the greatest thing when you're going to be talking for like 2 hours. I will say that, not the best thing when you're talking for 2 fucking hours. Alright. Trying to use all of these C programs functionality and it doesn't work. If your compiler is old, it may not support these more recent additions to the language. In that case, upgrade your compiler. For modern IDE compilers, your compiler may be defaulting to an older language standard. We cover how to change your language standard in lesson 0.12. When trying to use sign, count, or endl, the compiler says sign, count, or endl is an undeclared identifier. First, make sure you have the following line, include Iostream. Second, make sure each use of sign, count, and endl are prefixed by standard. For example, standard count hello world, standard endl. If this doesn't fix your issue, then it may be your compiler is out of date, or the install is corrupted. Try reinstalling or upgrading the latest version of your compiler. It'll be a bitch, but it'll help. Maybe, maybe not. Cool. When trying to use endl to end a printed line, the compiler says end1 is an undeclared identifier. Make sure you do not mistake the letter L in endl for the number 1. This is apparently a big fucking problem. Endl is all letters. Make sure your editor is using a font that makes it clear the differences between the letter lowercase l, uppercase I, and the number 1. Also, the letter capital is 0. Or, the letter capital O in the number 0. I did exactly what they told me not to do. Exactly what they told me not to do. When compiling with Microsoft Visual C++, you get a C1010 fatal error with an error message like unexpected end of file while looking for precompiled header directive. This is just a lot of error messages. When I compile my program, I get warnings about cannot find or open the PDB file. This is a warning, not an error, so it shouldn't impact your program. However, it is annoying. To fix it, go into Debug, Options, Settings, Symbols, Microsoft Symbol Server. Neat. I have another problem I can't figure out. Ask Google, ask Q&A. There you go. What the fuck is this? Neo Geo. Row card, Space Debris, Space Synth Remix. Damn, this is really freaking good. Damn! God, some video game music just fucking slaps. Just sometimes, it just fucking slaps. Build configuration, also called a build target, collection of project settings that determines how your IDEs will build your project. The build configuration typically includes things like what the executable will be named, what directories the IDE will look in for the other code and library files, whether to keep or strip out debugging information, how much to have the compiler optimize your program, etc. Generally, you will want to leave these settings at their default values, unless you have a specific reason to change something. When you create a new project in your IDE, most IDEs will set up two different build configurations for you, a release and a debug. The debug is designed to help you debug your program. Duh. It's generally the one you will use when writing your programs. Duh. This configuration turns off all optimizations and includes debugging information, which makes your programs larger and slower, but much easier to debug. The debug configuration is usually selected as the active configuration by default. We'll talk more about debugging techniques later. Release is designed to be used when releasing your program to the public. Literally, the fucking final version before it goes live. Because the release configuration includes all optimizations, this mode is also useful for testing the performance of your code, which we'll show you how to do later in the tutorial series. When the Hello World program, was built using Visual Studio, the executable produced in the debug configuration was 65 kilobytes. Where's that That might be kilobits. Right? Yeah, that might be kilobits. Whereas the executable built in the release version was 12 kilobits. Is it bytes or bits? I know there's a difference. That's not what I'm asking. I'm asking which one is bytes and which one's bits. Which one is the capital, which one's the lowercase? It might be bits. I think that's bits. I don't know. Although you can create your own custom build configurations, you'll rarely have a reason to unless you want to compare two builds made using different compiler settings. Best practice, use a debug build configuration when developing your programs. When you're ready to release, use the release. Duh. That really is common sense. I don't use that often, but that truly is common sense. Multiple ways to switch between debug and release in Visual Studio. Oh. And I have a configuration manager. So right now I'm writing for x86, it looks like. Okay. Yeah, it's already set to debug. You can also access the configuration manager dialog by selecting build menu. And then code block, same thing. Alright. Configuring your compiler extensions. The C++ standard defines rules about how programs should behave in specific circumstances. And in most cases, compilers will follow these rules. However, many compilers implement their own changes to the language, often to enhance compatibility with other versions of the language. For example, C99, or for historical reasons. I've lost my place. With other versions of C++ language C99, or for historical reasons. Okay. These compiler-specific behaviors are called compiler extensions. Wait. Writing a program that makes use of a compiler extension allows you to write programs that are incompatible with C++ standard. How the fuck? I'm sorry, this is gonna be an aside. How the fuck did I read so well in high school, and now I get lost halfway through a paragraph? Where the hell I was? Like, I don't know. I don't know how I was in the quote-unquote gifted class, when in reality, I struggle to read sometimes because I fucking lose my place just randomly. I'll be in the middle of reading and mid-sentence I'll just be like, where the fuck was I? Or hell, after an entire paragraph I just read, I'll be like, wait, what did I just say? What just happened? I don't even remember what I just read. And I'll just have to read the paragraph again. On rare occasions, I had to do that 5 fucking times before I'm like, wait, what? Read it again. What? Read it again. Just fucking keep going. I don't care at this point. It's just like, it's not that I didn't understand something. It's that I'll be reading something while something else in my head is happening as well. I don't know. Like, you're trying to have a conversation with somebody while also somebody's trying to have a conversation with you. And your mind is focusing on both. It sucks. It sucks a lot. Again, I have no fucking idea how I was reading a fucking... What was it? What was it I was reading at that time? The Chronicles of Narnia? Like... Heptology? Heptilogy? Heptrilogy? How many Chronicles of Narnia are there? Like 7? Anyways. Aside over. Writing a program that makes use of a compiler extension allows you to write programs that are incompatible with C++ standard. Programs using non-standard extensions generally will not compile on other compilers that don't support these same extensions. Or if they do, it may not run correctly. What the fuck is this song? Wangan Midnight Maximum Tune. Taillight. Some of these games, I have no fucking idea what the hell they are. Frustratingly, compiler extensions are often enabled by default. This is particularly damaging for new learners who may think some behavior that works is part of the official C++ standard, when in fact, their compiler is simply over-permissive. Because compiler extensions are never necessary and cause your program to be non-compliant with C++ standards, we recommend turning compiler extensions off. Disable compiler extensions to ensure your programs and coding practices remain compliant with C++ standards and will work on any system. Oh yeah, should I also mention, quite a lot of time, I have to use music in order to focus. And by that I mean, like, for me at least, music makes my head shut up. So I can just think for myself. That's what I found, is just like, if I feel like there's a lot of fucking shit happening in my head, music. So instead of having 5 different thoughts, my mind focuses on the music so I can actually think in at least only 2 directions. If that makes sense. My mind is fucked. And I wish that I didn't have to deal with it. But it's me. Anyways, to disable compiler extensions, right-click on your project name in the Solution Explorer window, then choose Properties. Oh, so... which one? So, this one. Properties? From the project dialog, first make sure the configuration field is set to all configurations. Disable... where are we? Where are we? C++? Language. Disable language extensions, yes. Za. Is that it? I guess that's it. Xcode users can refer to Rory's comment, who kindly provided instructions. Rory? I really shouldn't have gone into the comments just in case something was down there. I didn't read any of them. I have no idea. These settings are applied on a per project basis. You need to set them every time you create a new project or create a template project with those settings once. Use that to create new projects. Ugh. Oh yeah, which did they set? So they still have active Windows 32. Okay. Apply. Okay. Okay. Configuring your compiler, warning, and error levels. When you write your programs, the compiler will check to ensure you follow the rules of the C++ language. If you've done something that definitely violates the rules of the language, during compilation, the compiler will emit an error, providing both line number containing the error and some text about what was expected versus what was found. The actual error may be on that line, or on a preceding line. Once you've identified and fixed the erroneous lines of code, you can try compiling again. In other cases, the compiler may find code that seems like it might be an error, but the compiler can't be sure. Remember the motto, trust the programmer. Even though sometimes the programmers can't trust themselves. Then again, to be fair, there's a thing called, what is it, rubber duck programming? Where somebody literally just talks to an inanimate object, like I'm doing right now to a microphone, and nobody... Huh. In such cases, the compiler may opt to issue a warning. Warnings do not halt the compilation, but are notices to the programmer that something seems amiss. Best practice, don't let warnings pile up and resolve them as you encounter them, as if they were errors. In most cases, warnings can be resolved either by fixing the error the warning is pointing out, or by rewriting the line of code generating the warning in such a way that the warning is no longer generated. In rare cases, it may be necessary to explicitly tell the compiler to not generate a particular warning for the line of code in question. C++ does not support any official way to do this, but many compilers offer solutions via non-portable pragma directives to temporarily disable warnings. By default, most compilers will only generate warnings about the most obvious issues. However, you can request your compiler be more assertive about providing warnings for things it finds strange. Turn your warning levels up to the maximum, especially while you are learning. It will help you identify possible issues. Okay. So let's go back into properties. All configurations for my general. There's a lot in general. Warning level. Yeah, I'll just do level 4. I don't know what turning on... Oh, do not choose enable all warnings or you will be buried in warnings generated by the C++ standard library. Got it. Got it. No wonder it's literally enable all warnings /wall. Got it. Apply. Treat warnings as errors. Oh, my bad. I shouldn't have done that. Go back into here. General. Yes. Okay. We're almost done with... I think we're almost done. Oh, this is the last... Okay. Last part of Chapter 0. With many different versions of C++ available. Excuse me. Whew. Wow, excuse me. I am very fucking tired. How does your compiler know which one to use? Generally, a compiler will pick a standard to default to, often not the most recent language standard. If you wish to use a different standard, you'll have to configure your IDE compiler to do so. These settings are applied to the active project only. You need to set them again when you create a new project. Learn CPP uses 17. If your compiler is not capable of C17, you won't be able to follow all lessons, though the majority is unaffected. Make sure you're using an up-to-date compiler so you can compile all the examples yourself. There is an example at the end of this lesson which you can use to test if you set your compiler correctly. Note that language standards are named after the years in which they were finalized. aka C++ 17 was in 2017. However, when a new language standard is being agreed upon, it's not clear in what year the finalization will take place. Consequently, in progress language standards are given code names, which are then replaced by the actual names upon finalization for the standard of the standard. Sorry. For example, C++ 11 was called C++ 1x while it was being worked on. You may still see the code names used in places, especially for upcoming versions of the language standard, which won't have a final name yet. Here's a mapping of code names to the final names. So yeah, 2a was plus 20. I remember that just used to be 2a when I started. So I guess I finished that. Setting a language standard in Visual Studio. As of the time of writing, Visual Studio 2019 defaults to ++14 capabilities, which does not allow for the use of newer features introduced in C++ 17 and C++ 20, some of which are covered in future lessons. What the fuck is this? Oh, Super Metroid. Metroid Metal. Huh. Fucking rocking out. To use these newer features, you'll need to enable a newer language standard. Unfortunately, there is currently no way to do this globally. You must do so on a project-by-project basis. To do so, open your project and go to Project menu, Application's name, Properties, then open Configuration Properties. From there, you can set the C++ language standard to the version of C++ you want to use. So, here, Properties, we're in Language, C++ language standard. So they want 17. I'll do 17. Apply. Right, that's the right one? Yeah. There's also C language. I don't know what to do with that. I guess ignore it? I guess. At the time of writing, we recommend ISO C++ 17, which is the latest stable standard. If you want to experiment with capabilities from the upcoming C++ 20 language standard, choose that. Just note that support may be spotty or buggy. Hitting code blocks, I don't have code blocks. I'm not using code blocks. Same language standard in G++. In testing. Okay, so... You know what? It might actually be more beneficial for me if I actually write this out. Why are there so many? Also, why is my... God. You know what? Fuck it. Let's not write it out, because for some reason, the lights on my keyboard are out right now, and I can't fucking see anything. Paste. Oh. Yeah. Get rid of that. There we go. So, what is it? Control F5? Oh. No. What happened? Line 29. I guess we'll do that. Where is it? Include. Nope. No, 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 no. Okay, it had the thing. Whatever. What did it? Whatever. Where the hell are the carrots? There they are. What's it asking? PCH.H? Oh, it doesn't. Oh. Hmm. I don't know how to fix this. Let's see. How do I just do that? General. That's fine. Language. No. What if I try that? What if I do PCH dot H? No. Where the fuck are the carrots? What the fuck? It just doesn't like... What am I doing wrong? Huh. Is this not? Should be that. It's default. I don't know what I'm doing wrong. I have no fucking clue what I'm doing wrong. Is it that this Visual Studio is not fully compatible? Fucking really? Fucking really? God, that fucking sucks. Cause turn standard count size array and 1, 2, 3. Turn size of arts. Yeah, I have no fucking clue why it doesn't want to work. I don't know. So it wants to look for a precompiled header, which I don't have. I don't know how to fix this. Well, this is about where I was gonna end it anyways. I'll see about fixing this next time. Maybe it's the wrong Visual Studio that I grabbed. Possibly. Since I didn't grab it from their download, I grabbed it from Microsoft's download. So it could just be the wrong thing I downloaded. But yeah, this was fun. This was fun, doing something a little bit different. Hopefully it was fun for y'all. I know it's probably not the most entertaining thing, but hey, fucking education, learning, for free! For free with people. Yeah. So yeah, I hope you enjoyed it. I guess next time we'll do chapter 1 after I figure out what the fuck is wrong with this. And yeah, I know it's a short one, but I was also kind of late. I'll see y'all. What is today? What is today? Today's Saturday, so yeah, I'll see you tomorrow. Y'all have a good day. Bye.